Now we're going to review equations of lines. So first of all, on your math chart, there are three equations of lines, and I can give you an insert for your journal in class. One of the easiest ones to graph is the slope-intercept form, y equals mx plus b. So the lowercase m represents the slope of the line. So if I were to go ahead and get a highlighter, this is the slope. So you're going to substitute in for m. The b represents the y-intercept. So that's where it crosses the x-axis, the y-axis. Now, if you're using the next form, this is called the point-slope form of a linear equation. So you use it when you have a point, two coordinates for the point, and the slope. So the slope's the same. You still have the m here, and you're going to substitute into that. The x1 and the y1 are the coordinates for the known point. Notice how I don't have the y and the x highlighted here. We do not substitute in for those. Now, a line with a y-intercept b contains the point 0, b, because on the y-axis, the x-coordinate will always be 0. A line with an x-intercept a contains the point a0. So if you're on the x-axis, that crosses the y-axis when y is 0. So your 0 will be on the y-axis, and your x-intercept is a. Vertical lines are in the form x equals whatever that intercept is. Notice it's not y, and it's not on your math chart. So you're expected to know that vertical lines are x equals whatever that number is where it crosses on the x-axis, also known as the x-intercept. The slope-intercept, in my opinion, is one of the easiest ones to use when you know the slope and the y-intercept. Don't forget the y-intercept is b. All right? So see here, I have 0, b is the y-intercept. It is the best form when both the slope and the y-intercept are known from the graph. So here in an example, we're going to write an equation for the line for the graph below. And I've already started, I've got 3 points to choose from, and I need to find the slope. I'm going to go ahead and just start from this point here and use these two. You could use A and B, B and C, or A and C, any 2 points on here. You can use any 2 points. So using from B to C, you can see that the rise is a -2, and the run is a +3. We always go left to right on the run. So the slope is -2 over 3, rise over run. Then I'm going to use the y-intercept. See how it crosses the y-axis here where y is 4? So that tells me that b is 4. So since I know the slope and the y-intercept, the easiest form to use is the slope-intercept form. Y equals mx plus b. We substitute in for the m and the b. We leave the y and the x alone. So it ends up looking like y equals -2/3 x plus 4. The point slope form is handy when you know the coordinates for 2 points, and you may or may not know the slope, and not only that, when the line is not vertical. So if it's a vertical line, that's x equals, and so the point slope form won't work for that. So the first step is to use the 2 points to find the slope. Then, once you know the slope, you're going to use that from that slope from step 1 and your given. So if I look at your given point, remember you had 2 points, right? So you can use any one of those 2 points for the equation in the point slope form. Then you're going to use a distributive property, multiply the slope, because you're going to get this y minus y1 equals m times x minus x1. Multiply that out and solve for y. It'll be clearer when we go through an example. So let's go ahead and do that. So here I have an equation for the line at the graph at right. Now I can use the 2 points or slope of a line, which is the, let me go ahead and write that out for you, just so we know it. And that slope of a line is m equals y2 minus y1 over x2 minus x1. Personally, I prefer just counting on the graph. So let's say I go ahead and substitute it. y2 is 4, y1 is -5, x2 is 3, and x1 is -2. So I would expect the answer to be 9/5. Now what I did in this problem is I just went ahead and counted. The run here is 5, and the rise is 9. So I got the same answer. The rise over run is 9/5. Now I don't know the y-intercept, so I'm going to have to use the point slope form. I know this point, -2, -5, so I'm going to go ahead and use that. I could have used the other point, D. That would have worked fine, but I just happened to grab this one, point E. The point slope form is y minus y1 equals m times x minus x1. Don't forget that we are only substituting in for y1, for m, and for x1. So y1 was -5, so y minus -5 equals 9/5, that's our slope, times, parentheses, x minus -2, because -2 is x1. I went ahead and changed the minus and negatives to plus. Y plus 5 equals 9/5, x plus 2. And then I go distribute the 9/5, that becomes 18/5, and let me get my pen. This is 3 and 3/5. So then I subtract 5 from both, 3 and 3/5 minus 5. You could get a common denominator or figure out some other way to get that 1 and 2/5. So my answer is y equals 9/5 x minus 1 and 2/5. If you wanted to, you could have changed this to decimals and you would have gotten the right answer as well. Y equals 1.8x minus 1.4. The last form is the standard form. It looks like ax plus by equals c. You really don't normally want to put things in this form. It's not as handy. But sometimes you'll be given this form. This is standard form. And you'll have to rearrange it to find the slope-intercept form of the line. So, quick reflection. How can you determine the equation of the line if you only know the x-intercept and the y-intercept? I'll give you a little clue here. So I'm going to give you a little bit of help. X-intercept is really, x is going to be a, comma, and it's 0. Because when it crosses the x-axis, it's a, comma, 0. The y-intercept will be 0 because it's on the y-axis, comma, b. So when I give you the x-intercept and the y-intercept, I'm really giving you more than one number for each point. Don't forget the zeros that are included there. And hopefully that will help you come up with an answer for this question.